Capacitance Class 12 Physics. In Class 12 Physics, capacitance is an important topic in the field of electrostatics. It deals with the ability of a capacitor to store electric charge when a potential difference exists between its plates. Here are some key points you might want to know about capacitance. Capacitance definition. Capacitance, C, is the property of a capacitor that represents its ability to store electric charge per unit potential difference. Mathematically, it is defined as C is equal to QV, where Q is the charge stored and V is the potential difference across the capacitor. Capacitor. A capacitor is a device designed to store and release electrical energy. It consists of two conductive plates separated by a dielectric material. Unit of capacitance. The unit of capacitance in the International System of Units, SI, is the farad, F. It's a large unit, so capacitances are often measured in microfarads, μF, and picofarads, PF, for practical purposes. Factors affecting capacitance. Plate area. The larger the surface area of the plates, the higher the capacitance. Distance between plates. A smaller distance between plates leads to higher capacitance. Dielectric material. The type of dielectric material between the plates affects capacitance. Some materials increase capacitance, while others decrease it. Dielectric materials. Dielectric materials are insulators placed between the plates of a capacitor to increase its capacitance. They reduce the electric field between the plates and thus increase the charge that can be stored. Parallel plate capacitor. It's a simple type of capacitor consisting of two parallel plates with an insulating material in between. The formula for its capacitance is C is equal to epsilon asterisk AD, where epsilon is the permittivity of free space, A is the area of the plates, and D is the distance between the plates. Series and parallel capacitors. Capacitors can be connected in series or parallel to modify their overall capacitance. In series, the reciprocal of the total capacitance is the sum of the reciprocals of individual capacitances. In parallel, the total capacitance is the sum of individual capacitances. Charging and discharging. Capacitors can store and release charge. When connected to a voltage source, a capacitor charges over time. When disconnected, it discharges, releasing stored energy. Remember that these are just key points, and there's a lot more to explore and learn about capacitance in Class 12 Physics. You might study topics like energy stored in a capacitor, time constants, and their applications in circuits.